Miss Jody here again with a video finishing up Hess's law. We did the video last time and then I left you with two questions that you were to be working on. And these two particular questions, I'm going to go over those for the answer video here. Okay, so when we look at this first question, it's what is the change in enthalpy at standard conditions of the following reaction? 2NO2 gas plus oxygen O2 as a gas and 2NO2 as a gas, 2 moles. Okay, and is it exothermic or is it endothermic reaction? So these are pretty easy, and you probably looked at your book and you saw they were not too hard to do, but just as a review. So what we would do is, first of all, we'd have to figure out the change of enthalpy of formation. So remember when the little F is there, that's going to be the formation side of things. And so we can look at the amount, the change in that in the formation. And if you look at the chart in your book, and I think the chart was back on page, all the way back, 462. So if you looked at the chart, the standard enthalpies of formation for NO2 is 90.3 kilojoules per mole, and that's just right off the table. And the standard enthalpy of formation for O2, and since O2 is close to that element side, but it's the homonuclear diatomic element, remember we said it's 0. And then we had the standard formation, or the standard enthalpy of formation for the NO2 gas, and that on the chart was 33.2 kilojoules. So all you had to do was then take that amount and you're going to put that into Hess's law. So if you remember what Hess's law is, remember that we take the sum. So our change in enthalpy at standard conditions will be the sum of the change in the enthalpy of formation of the products. So we take the products first. So over here is the product side. So this is why my arrow goes like this. So I'm going to take my product side, and I know I have in my product side 2. So if you look at the equation, I had 2 sets of NO2. So if each one of them is 33.2, then that means I have to multiply that. So 2 moles times 33.2 kilojoules per mole, and that will cross out the moles, cross out the moles. That gives me 66.4 kilojoules. So that's my first set of energy going on there, how much energy is involved there, and that's of the products. And so, and of course, if you look at the product side, there was only one product. Now, if there had been 2 products, then you have to add them together, because you remember that this sign is the sign of summation. That means adding them together. But I only had the one, so there's my answer for that side, so the products. So then I take my products, my change in enthalpy of formation of my products, and I subtract the sum of the change in enthalpy of formation standard conditions of my reactants. So then I go to my reactants, there's 2 of them. And so with this one, the NO is 90.3 kilojoules per mole. But if I look back up in the equation, there's 2 of them. So I've got to multiply that by 2. And then my oxygen, we know there's only 1 mole of it anyway, but it's 0 anyway. But we could still write it out to keep it straight if we need to. So on the reactant side here, I had 2 moles times 90.3 kilojoules per mole. That will cross out your moles and you'll be left with kilojoules. That equals 180.6 kilojoules. And then 1 mole of oxygen, which is 0 for the energy there per mole, is just 1 times 0 is 0. So if I add those 2 together, it comes to 180.6 kilojoules. So I have 180.6 kilojoules. So I start on my product side, 64.4 minus 180.6, and my total comes to negative 114.2 kilojoules. And so once I see that negative sign, then I know it's exothermic. And so it's as easy as adding them up, making sure you have the right amount with how many moles you have, and then figuring out the end what you have, a negative or a positive for the exothermic or endothermic. Okay, then the second one was the same way. Some gasoline companies put a small amount of liquid ethyl alcohol, which is this formula, into their gasoline. And what is the change in enthalpy at standard conditions for the complete combustion of this chemical? So they don't give you the formula, and you have to create the formula, and that's easy because you take the ethyl alcohol, which is C2H6. Now do note, when I originally wrote this, and if you had trouble solving it and it wasn't matching anything, it's because I wrote H2. And that's my bad. I do that sometimes. And so it's supposed to be H6O. So if yours doesn't match this, it's because of my particular error. So sorry about that. Hopefully you figured that out when you had looked at the chart, because there was no C2H2O. Okay, so C2H6O in its liquid form. Now the reason we get it in that liquid there is because we've seen in the original problem that it's a small amount of liquid ethyl alcohol. And that's important because when we look at the chart and we're talking about the enthalpies of formation, remember, it's going to be a different amount to form a solid, or to form a gas, or to form a liquid, or to form a solid. So say for instance H2O as a gas, the formation is negative 242, but as a liquid it's negative 286. So there's going to be a different amount. So you have to make sure that if they give you clues as a liquid, then you stick it in there. So because you have to know the state in order for it to be something that you can solve using that chart with the formations, because they are based on the states. Okay, so we have this is a liquid, O2 is a gas, which we know is as a gas, and then we have our carbon dioxide, eventually will be I'm sorry, I should have put in here in gas, and then our water as a gas. And so we have the change in enthalpy of formation for each one of these. So I look up on the chart, and for this particular molecule, the ethyl alcohol, it's negative 278 kilojoules per mole. So and there's only one of it. And this one, there's oxygen, O2, molecular oxygen, and there's 3 sets of it. But we know that just equals 0 anyway. And then carbon dioxide is negative 394 kilojoules per mole, per 1 mole of that. But we'll end up having 2, so we'll have to multiply that. And then the H2O in its gas form would be negative 242 kilojoules per mole. So when we look at that, once we get them all in the amounts, then all we have to do is stick it into Hess's law. And so we have the change in enthalpy is the summation of the change in enthalpy of formation at standard conditions for the product. So I start with the product side. So I find these guys over here, and they have to come over here. And so we have what? We've got 2 moles of carbon dioxide, 2 moles multiplied by negative 394, which equals negative 788. And then I've got 3 moles of H2O at negative 242. So 3 moles at time multiplied negative 242 would equal negative 726. And then we have to sum these up, because remember this sign is the summation of those. So we have to add these together. Negative 78 plus negative 788 plus negative 726 equals negative 1,514 kilojoules. So that's my first side, my product side. Then I do the same thing with the reactants. I find the reactants up here, which is these guys here, and they've got to go there, the summation of these guys. So I've got, 1 mole of this, so 1 mole. So it's equal to negative 278 kilojoules per mole. So that's negative 278. And then I have 3 moles of oxygen, 3 moles of O2, but we know that energy is just 0, so it's just 0. So when I add these together, negative 278 plus 0, I have negative 278. So then I take these two, negative 1,514 kilojoules minus, because there's my minus in my Hess's law, minus negative 278 kilojoules, and my total equals, I had to put it over here because I ran out of room trying to squeeze it in there, and negative 1,236 kilojoules. Okay, so it's real easy. It's just a matter of adding and subtracting and keeping them on the right side between the products starting and then the reactants. And that sums up the answers to the two calculations on Hess's law.